Myself, K. Selvaraj from Department of Electronics and Communication Engineering, Welltech Multitech, Dr. Rangarajan, Dr. Sakundala Engineering College. Our project team members are Bhaskar, Santosh Kumar, and Vinayam. Our project title is Singlet Oxygen Luminescence Detector based on low cost NIR diode. Our project guide by Dr. A. Mohammad Abbas, PhD, Assistant Professor of ECE. Our project abstract molecular oxygen is existed to singlet oxygen, a highly reactive chemical. It is commonly generated by photoexcitation of dyes. A measurement of single oxygen is unwanted thing, but it was needed during a development of various photosensitive chemicals and drugs. The existing method for a detection of luminescence of single oxygen is very expensive, so the need of another method is required. In this setup, luminescence can be detected by high sensitive photodiode. Since the luminescence from the singlet oxygen is unstable and it lasts for few seconds only. In our cases, we are using a high sensitive NIR pin diode. The singlet oxygen luminescence is detected at 1200 nm. Our project objectives: singlet oxygen is the lowest excited state of the dioxygen molecule. Its lifetime is solution is in the microsecond range. It undergoes several reactions with organic molecules. These reactions have been studied for many years. The singlet oxygen is often prepared by a process called photosynthesization. A photosynthesizer is irradiated to its singlet excited state, but the formation of singlet oxygen is often unwanted for various light sensitive compounds. During the development of new sensitive chemical and dyes, there is need to evaluate the amount of singlet oxygen during photoexcitation. During the formation of singlet oxygen, a luminescence is produced. There is need to measure the luminescence of singlet oxygen, and its value is used in the formation of various photosensitive compounds and drugs. There is already a exciting method to measure the luminescence of singlet oxygen, but the was very complex and expensive. This is our literature survey. Singlet oxygen O2 is framed during photoexcitation of colors and manufacture colors under high impact conditions. Photodynamic treatment of disease, cancer, and inactivations of microorganisms depend on photosynthesis. A group of synthetic compounds whose activation by light outcomes in the generation of responsive oxygen species including O2. The progress in semiconductor innovation have prompted the rise of delicate finders which can be utilized for the detections of O2 luminescence. Utilize avalanche photodiode cooled to 77K with charge recalculation framework. Demonstrated the negative feedback NIR diode working in single photon mode fit for the O2 luminescence detections in natural medium. At long last, enormous region photodiode can be utilized for O2 dosimeters, including the time shuttle estimations. This is our block diagram. In the setup, the molecular oxygen is converted into singlet oxygen with the help of organic compounds such as tetraphenylpurine, rose bengal, dimethyl sulfide, ethanol carbon tetrachloride. Then the simple electronic setup is developed by using breadboard, DC to DC converter, capacitor, resistor, high sensitive photodiode. When the chemical compound is reacted to produce singlet oxygen, then the finished setup is placed near to the chemical reaction. When the light passes through the diode, immediately light energy is converted into electrical energy and get amplified through Arduino. This is our circuit diagram. We have designed a simple electronic circuit using capacitor, resistor, DC to DC converter, Arduino and photodiode. Since the luminescence has to be measured only by high sensitive photodiode. When the singlet oxygen is produced, a setup is placed near to the reaction. Luminescence of singlet oxygen falls on the photodiode. Suddenly, the light energy is converted into the electrical energy, and the reverse bias voltage enter the DC to DC converter. The signal is amplified and fed into the Diode microcontroller. From there, it is connected to personal computer via a USB port. The output is displayed on the screen. Likewise, the process continues for different chemical reaction for the formation of singlet oxygen. This is the easiest way for the detection of singlet oxygen compared to existing one. It is also cost efficient as well. The output gets recorded for different chemical reaction. First, when TTP mixed with carbon tetrachloride, singlet oxygen is formed and luminescence get detected. Then the signal is amplified and sent to Arduino board. From the signal is fetched to PC using USB port and the output gets displayed on the PC. Likewise, 3 to 4 chemical reactions were conducted and output varied significantly for different chemical reaction. Likewise, process is conducted as the setup is easy to understand and comparatively portable. Then the existing method, it is also called efficient compared to existing one.